Hello, my name is Bob NIelds and welcome to the Introduction to Databases Part 2. Similar to the last video, I wanted to spend some time reviewing the second part of the assignment for those who were assigned these particular questions, and for those who were not, it's also important that you also understand the answers to these questions in regards to preparing yourself for the course. All right, so these particular questions as we walk through it, as well as a relational database. What is a relational database? What is the benefit of a relational database? Define how relational databases are more efficient than other databases. What is normalization? What is the benefit of normalization? What is the Dbms? What does a Dbms do? And what are some of the popular ones used today? So let's go ahead and get started. A relational database. Once again, I went out and Googled, kind of copied some answers, hopefully to at least get started with a conversation here. A relational database is a collection of data items organized in a set of formally described tables from which data can be accessed or assembled in many different ways without having to reorganize the database tables. Wow, okay, what's that mean? Well, once again, when we talk about a relational database, what the relational database is that instead of that flat file system that I kind of mentioned in my previous video, we break everything up into, really the term is entities, and we'll start talking about that next week, where we sit back and we classify an entity and we draw a relationship with that entity. Specifically, student would be an entity. And then the courses that you take could be an entity. And we draw a relationship. That is what a relational database is. Each entity then creates its own table. And so a table is basically a collection of data related to that particular entity, if that makes sense. If it doesn't, don't worry about it too much right now. We got a whole course to talk about it. But with that said, that's what this is all about. That's what a relational database is. It was derived quite a while ago with the idea of scalability and reduction of data, redundancy, I should say, of common data. And we'll talk about that a little bit more as we progress through this video. But for the most part, a relational database is the norm in the industry. There are some things called NoSQL out there now, which is a non-relational database. But for the most part, relational databases are still very, very popular, if not pretty much seen in about 99% of all applications that are actually written out there. So what's the benefit? In addition to being relatively easy to create and access, which it is, and you'll see that, a relational database has an important advantage of being easy to extend. That's that scalability piece. So after the original database is created, new data category can be added, more data can be added, and it's very easy without having to modify existing code within that. Now, as a brand new programmer, it might not make much sense, but as a seasoned programmer like myself, it makes a lot of sense with the fact that, back in that whole flat file, every time we need to extend it or add a new data or do something like that, we would have to go into each program and modify those. So in a sense, a relational database, really its main benefit is its extendability. It's also its scalability. So if somebody decides to, and we'll talk about this a lot over the next several weeks, if a student wants to take one course, the database only holds that information on one course. If a student wants to take 20 courses, the database will hold information of 20 courses. If it wants to take 1,000,000 courses, it can do the same thing. Hopefully that makes sense a little bit. That's all I really care about at this point in time, just a little bit. How are relational databases more efficient than others? Well, again, there's others. What's that mean? You could go back in history. There was hierarchical databases before relational databases. But for the most part, what I mean by this question is really this whole flat file piece. And of course, Excel, in a sense, is a flat file. If we look at this particular slide and you kind of see what I did here, I basically created, if you will, a student database. See the top of the Excel spreadsheet there called student database. All right. In there, there's some columns, fields, if you will. We call them columns in database world that are called student name, student ID, student gender, Course 1, Course 2, Course 3, Course 4, and Course 5. So in this case here, I have some data in this. So this is basically a spreadsheet that is holding information about the students, okay, within my student database, their ID, their gender, and basically the courses they have taken thus far. Is there anything wrong here that or any concerns you have? That way, if you look at this, I'll give you a second. I might sing or something, but I don't think I will. Okay, but if you kind of look at it, what are some of the issues here as I see it? I go, well, one might be is that if you notice, I got room for 5 courses. What happens if somebody takes a 6th course? No big deal. I go out and create another column, right? How about a 7th course, an 8th course, or a 9th course? But then what happens to the people who's only taken 1 course? As you see, those columns become empty. That's really inefficient, is it not? And empty fields? Well, in a database, it's very much inefficient. So our goal is to eliminate that. We don't want that in our database. But then we also don't want the limitations of how many courses somebody could actually take. And what's nice about a relational database is we can handle that. And so if somebody takes 1 course, as I just said before, there'll be 1 instance within the database. If they take 1,000,000, there's 1,000,000. All right? What else do you see here? Anything else? If you look at student gender, if you kind of look at that, you see male, female, female, male. All of a sudden, the male becomes the mailman, I guess. I'm not quite sure. What happens there? Well, what does that do to me? So if I decided, if my boss came to me and says, "Hey, Bob, can you tell me all the males that are taking courses at our college?" If somebody actually spelled male, M-A-I-L, and I have seen that before, trust me, that wouldn't come back. So now all of a sudden my results are wrong and they're inaccurate. A relational database, normalized database, we'll get into that a little bit later, basically handles that situation. And you'll see how that's done once again throughout the course. What's also anything you may see in there? How about the fact that all 4 of them took IT 100? And I have to put it in my database 4 times. Do you see that? Not that that's big a deal, but once again, a duplication of data over and over and over again. Is there a way to represent IT 100 a different way so we only have to have it in our database once and then reference it? That's something we're going to do. We don't like duplication of data. That's what this actually means. So we eliminate redundancy in it. So how's it more efficient? Well, a relational database can ensure, and I'm going to take it one more level, a normalized relational database, and again, we'll talk about that here in a few minutes, can ensure that our data has integrity, it's consistent, it lacks redundancy, and it's scalable. That's what our goal is, trying to create this data. That's what we're going to spend the next 15 weeks on, in trying to understand and build and then actually add data to and get data out in regards to retrieving data out of it. That's our goal, is to build a mechanism, a database that can handle all of this and be able to handle anything that's thrown at it. Hope that helps a little bit to get you started. I've been mentioning this word normalization. We're going to cover that. Probably starting in week 6 or so of the course, we'll start covering normalization. So database normalization, or simply normalization, is the process of organizing the columns and tables of a relational database to reduce data redundancy and improve data integrity. That's all it is. There's 3 rules. We'll introduce them to you, you'll practice them, and you'll see what we mean. It's basically a guideline on how to go about creating a database to make sure it's at its peak efficiency, that it does not have any possibilities of redundancy, and the integrity of the data, meaning we wouldn't have the word male in there, M-A-I-L, to represent M-A-L-E, will actually work, okay? And so we wouldn't have that anymore. We lose that possibility. All right. Also, what normalization will do is ensure that we can be scalable. Meaning, if I want to take 1,000,000 courses, my database can handle it, and I wouldn't end up with a 1,000,000 blank areas, if you will, columns, areas, fields, for somebody who only took 1 course. Make sense? What's the benefits of a normalized database? Well, This is a tough one here. I was trying to find a lot of different um, examples for you. I mean, so the internet came back with several narrow tables with fewer columns as characteristic of a normalized database. When useful indexes are available, you don't know what an index is. The SQL Server Query Optimizer is efficient at selecting rapid, efficient joins between tables. Blah blah blah. Let's don't worry about that right now. For the most part, the benefit is what I just mentioned before. If I sit back and go back to this previous one, it's going to reduce data redundancy and improve data integrity. That's really what this whole thing is saying right there. And we could be able to, if we build it correctly and normalize it correctly, we can get it out pretty fast. I gave you another link here to look at, and I also provided it on the video itself, outside the video itself. Go look at it. This is from Sybase, and it actually has a nice list of benefits of a normalized database. Some of you may understand, some of you may not understand, but they gave you about 10 to 20 different really good benefits. You may want to look at them. If you don't understand them right now, don't worry about it. By the end of this course, you will. Okay, maybe we'll go back to it. Also, if you search the internet, you'll probably find out there's some people think there's cons to a normalized database, including slower reading times. And that comes from the purpose that since we have relationships with all these entities, aka tables in a database, we got to join them back together again. And we do that with a select statement, SQL select statement. Once again, don't get too carried away here or too concerned about all these terms. But some people think that actually slows things down. I've never seen it slow it down enough to make it a difference, but this is where NoSQL came into play, type of database, which is more of a non-relational database. And we're starting to see more web companies go to non-relational databases. They think it's faster. They don't care about the redundancy and so on. So there's kind of a give and take there. But with that said, that's what we're trying to accomplish with all of this. So there's some cons out there. Just like everything in IT, you're going to recognize some people think it's good, some people think it's bad. Everybody has a different opinion about everything. But I'm going to say one more time. Relational databases are out there about 99% of the time in every application that's ever been created, at least at this point. So it's a good thing to learn. What is a Dbms? Another term I want you guys to, it's called a database management system. Basically, it's a piece of software, Access SQL Server, that is packaged to define, manipulate, retrieve, and manage data in a database. Dbms generally manipulates the data itself, the data format, field names, record structure, and file structure. It also defines rules to validate and manipulate this data. It's a very powerful piece of software that really takes care of your database in a lot of different fashions and so on. And this next one, what to do? Concurrency, concurrent access, meaning at the same time to the same database to multiple users. It can handle concurrency of multiple users. Once again, think of eBay. All those people hitting the same database at the same time, possibly the same product at the same time, possibly making a bid at the exact same time on the same product. How this database, Dbms, can help handle that for you. Security, making sure people can't get to it, and all the issues with security today. Dbms has helped that. Backup and recovery, very, very important. Every time, if you have data and you don't back it up, that's a means for disaster. You got to back it up somehow and make sure it's in a safe place, that if something happened to the place where the database exists, that you can restore it. I mean, think about that. I mean, think about Cincinnati State and their student database. If they didn't have that backed up and put on, off premise somewhere, that backup off premise, if God forbid a fire or a tornado or some other disaster happened at our campus, we would still want to get our previous student information up and running for all kinds of purposes you can only imagine. Integrity, and make sure that the database structure and rules improve the integrity of the database. It handles that for us. It handles our integrity. You'll hear the term referential integrity here, I don't know, in a few weeks from now. The database takes care of that. And finally, the data descriptions. A data dictionary provides a description of the data, and so it kind of handles all those pieces too. All right. What are some of the popular DBMSs out there? We kind of talked about this before. Microsoft SQL Server, we're going to be using that in this class. Oracle, Microsoft Access, IBM Database 2, DB2 is called, SAP Sybase, MySQL, and there's others. There's smaller ones and larger ones that are out there. These are probably the most popular ones that you'll actually hear about or be exposed to in your career, or at least early in your career. Okay, so this particular video, a lot of terminology. Once again, I welcome you to go back and re-listen to it if you like. But make sure you at least get an idea of what this is all about. When I say idea, a very, very high level, okay, I sort of get it. I'm not quite sure if I get it, but I sort of get it type of attitude. So we can now walk in and not everything is going to be foreign to you as we start talking about these terms. But I promise you, we'll go into grave detail on everything we talked about in these two videos throughout the course. And by the end of this course, you could look back on these two videos and say, I know everything this guy was talking about in the beginning, and I can actually discuss these now with my friends and family. Oh, you'll be a party animal, trust me. All right, so with that, that concludes this week, the first week of this course. Starting next week, we're going to dive in and start getting into database design and start understanding how to build a database based upon some requirements and so on. And some of the terms we talked about today, you'll start hearing about next week. With that, until then.